Hello all, welcome you to this lecture 10 of the chapter Motion in a Straight Line. Today we are going to discuss very important topics. So let's see what all are the topics for today's discussion. Okay. So the topics are, we will be discussing about the motion under gravity, equation for displacement in the nth second. Then we will discuss about stopping distance and stopping time. Then we will discuss Galileo's law of odd numbers. And finally, we will be discussing about relative velocity in one dimension. So, are you guys ready? I think you are ready, and let's move on to our first topic, that is motion under gravity. Okay, when we come to motion under gravity, we have to mainly discuss two cases. One is the downward motion of a body and the next one is the upward motion of the body. Okay, what is downward motion? Definitely, a body is moving in the downward direction, right? Vertically downward. So, in this downward motion, we have to know two main things. That is, one is the case of throwing a body in the downward direction. Okay. So, when you are throwing something, you have to apply a force. Am I right? And when you are applying a force, there will be an initial velocity in the downward direction. Isn't it? See here, I am giving an initial velocity, right? So, if you are throwing something, if in a question they are giving a body is thrown in the downward direction, you have to consider the initial velocity of the body. Okay. The next is the case of dropping. What is dropping? You are dropping something. I will take another object. Okay. Here is an object and you are dropping this. Okay. You don't have to apply any initial force or initial velocity. Right? See this? You are just releasing your fingers, right? So that the body is moving under the effect of gravity, right? Because earth is attracting this one. Okay, so what will be the acceleration of this body? That acceleration is called as acceleration due to gravity, which is represented using the letter G. You know that, right? And the value of G can be taken as 9.8 meter per second square. So that is what we call as free fall. Okay, free fall means a body is dropped, that is the initial velocity of the body is taken as 0 and the body is moving with an acceleration which is equal to g. That is acceleration due to gravity. So I hope you are clear about downward motion, right? Now let's discuss the case of upward motion. Okay, that is a body is moving vertically up, right? So in that case, you have to apply a initial velocity, right? You have to apply a force in order to throw a body in the upward direction, right? So definitely it will have an initial velocity, and when a body is thrown, just you listen here, okay? You listen to this object. A body is thrown, okay? A body is thrown. What happens? It moved to a certain height, right? Then its velocity becomes 0. So at the maximum height possible, the velocity, final velocity becomes 0. Then the body will come back. Is that clear to you? When you are throwing a body in the upward direction, you have to give an initial velocity. Then the body will move up, reach its maximum possible height. Then the final velocity becomes 0. Now the velocity becomes 0. Okay. And then the body will come back. Then the body will retrace its path. Okay. So that is what is happening in the upward motion. Clear to you? Okay. And this throwing vertically up can be taken as vertical projectile. Okay, it is called as vertical projectile. You know the rocket propulsion, right? rockets are moving in the upward direction. Okay, that's a vertical projectile. So that is an example, that projection of rockets is an example for one-dimensional motion. Its vertical projectile comes in 1D, that is motion in a straight line. You have other types of projectile like oblique projectile. Okay, and that projectile will be discussed in the next chapter, that is motion in a plane. Okay, so by understanding these basic things, let us move on to the mathematical equations concerned with this motion under gravity, that is downward motion as well as the upward motion. Okay, so let's see that. So we are going to discuss the downward motion. Okay, so in that we have discussed two things, right? One is throwing, alright? In throwing, the body will have initial velocity, alright? The body will have a initial velocity. Okay, now the next case is of free fall, alright? Free fall. Free fall means you are dropping so that your initial velocity is 0, okay, and the acceleration of the body is equal to minus g, alright? Okay, acceleration of the body is equal to minus g. Either you can consider it as minus g or plus g depending on the sign convention you are considering. Here I am considering the Cartesian type of sign convention, which we have discussed in previous lectures. Okay. Now, let's think that, okay, let's take an example. We are going to mainly discuss about this free fall case. Okay. So, let's take an example. Okay. Here is a building. Okay, here is a building, and this building have a height which is equal to h. Okay, and you are dropping something from the top of that building. Okay, you are dropping something from the top of that building. So here is that body and you are dropping that body. So the initial velocity will be equal to 0. So what I am going to calculate is the final velocity at this bottom. Okay, what is the final velocity at the bottom? So that is first we are going to discuss final velocity. Choose a different color. Okay. What is the final velocity? Okay, final velocity. Final velocity, the equation is V is equal to U plus AT. You remember this equation, right? Because this motion is with a constant acceleration. So you have to use kinematics equation, right? Okay. V is equal to U plus AT. Your initial velocity is 0. So, and your final velocity, what about the final velocity will be in the downward direction, right? The final velocity, here is the body, okay? Here is the body. That final velocity V will be in the downward direction. So that is negative. Minus V is equal to U. U is 0. Okay. So U is 0. And what about A? A is minus G and T is the time taken. T is the time taken. So your equation is V is equal to GT. So this is the equation for the final velocity. V is equal to GT. Okay. What is the sign convention followed? What is the sign convention followed? I think you guys are clear about that, right? This is the sign convention. You are familiar with it. This direction is negative. This is positive. This is positive. And this is negative. Okay, this is the sign convention we are following. Okay. Another equation for the same thing, that is the final velocity. Okay, we know that V square minus u square is equal to 2as, right? Now it is minus v the whole square minus u is 0, right? So 0 square is equal to, what about this? It is 2 into, the acceleration is minus g, and what about the displacement? The displacement is also in the negative direction, right? Because the body is moving in the downward direction, then the displacement direction is also negative. Okay, so that is minus h. Clear? So minus v the whole square becomes v square is equal to, this minus into minus will become plus, so it is 2gh. So another equation for final velocity v is root of 2g capital H, alright? 2gh. I hope it is clear to you. Okay. Now we are going to derive an equation for the time taken for this body to reach at the bottom of this building. Okay. So let's see the equation. That's a time taken. Time taken. Okay. Time taken. We know that the s is equal to ut plus half at square. Alright? Now what about this displacement? It is minus h is equal to, why minus h? Displacement is in the downward direction, right? Okay. U is 0, so that ut term become 0. Now what is remaining? Half into, what about acceleration? It is minus g into t square. Alright? So this negative on the left hand side and negative on the right hand side will get cancelled, and upon rearranging you get your time is equal to root of 2h divided by g. Okay, root of 2h by g. So these are the formulas and the concept you have to remember regarding the downward motion of a body under the gravity. Okay, now let's discuss the case of upward motion. Let's discuss the case of upward motion. So let's consider you are throwing up a body from a particular level. Okay, so let's consider this is the level, and from this level a body is projected vertically. Okay, that is, a body is thrown up vertically with an initial velocity, say u. Then after some time the body will reach its maximum possible height, right? Okay, that's the maximum possible height. Then the final velocity will be equal to 0. Okay. And after that what happens? After that the body will start to come back to the ground. Okay. Suppose if the height to which the body is moving be h, okay, then let's derive the equation for the height, the time taken, and many things. Okay, so let's see that. So first we are going to derive the equation for the height. Okay, so we are going to derive equation for height. We know that the v square minus u square is equal to 2as, right? From this, what about v? V is 0. Okay, because the body is at its maximum height. Okay, then the final velocity is 0. Now minus u square is equal to 2 into, what about the acceleration? Always g will be acting downward, so that is negative. Okay, so minus g into, what about the displacement? Now you are throwing body in the upward direction, so displacement should be positive because upward direction is positive. Okay, so which is equal to h. So from here you can say that your h is equal to u square by 2g. This is the equation for the height of the body. Okay. Now Let's derive the equation for the time taken. Okay, the time taken. Second is for time taken. Time to reach maximum height. Time to reach its maximum height. Okay. We know that V is equal to U plus AT. Alright? Here the final velocity is 0 is equal to U, that is initial velocity, minus GT. Why? Because G is in the downward direction. Upon taking this minus GT to the left hand side, it becomes positive. So GT is equal to U. From there, your time is equal to U by G. Okay, the time is U by G. Clear? Now you have to understand a very important point. Okay, you have to note a very important thing. That is, the time of ascent is equal to the time of descent. Okay, what is mean by ascent? Ascent means moving up. Yes. Okay, ascent. Now, time of descent. Descent is D, that is moving down. Okay. This time of ascent will be equal to time of descent. Okay. So, time to move up will be equal to time to move down. The same distance. Okay. That is the H. Okay. So, what is the total time for a body to reach the ground after it is projecting up? Okay. In the second equation, we was discussing time to reach the maximum height. Now, I need the time for that body to come back to the ground. Okay, it moves from ground and come back to ground. What will be the time? 2 times U by G. You get the logic? So that total time will be equal to T up plus T down, alright, which is U by G plus U by G, which is equal to 2U by G. Okay. So these are the important formulas you have to remember regarding the upward motion under gravity. I hope it is clear to you, right? So let's move on to our next concept, that is, we are going to discuss the equation for the displacement in the nth second. Okay. So, you have already learned an equation for displacement, that is S is equal to ut plus half at square. Alright. Either you can say nth second or you can say tth second. Okay. For time, if you consider the letter n, then it is nth second. For time, if you consider the letter t, then it is tth second. Okay. So, I think you guys are familiar with t, right? So, I will take it as tth second. Okay. Equation for displacement in the tth second. Okay. So, what you have to understand? You have already learned the equation S is equal to ut plus half at square, right? Then now you are thinking why we need this equation. So we need to understand the difference between them. First of all, we need to understand the difference. Then we will go to the derivation part. The derivation is also important. Okay. So listen here. When you say that S is equal to ut plus half at square, you are considering the displacement from 0 seconds to t seconds. Okay. Here you are considering displacement from 0 seconds to t seconds. Okay. For an example, if you say 5 seconds, then you are considering the displacement, okay, from 0 seconds till 5 seconds. Okay, from 0 seconds, that is from the starting to the end of 5 seconds. What is the displacement? So for finding that, you have the equation s equal to ut plus half at square. Okay. Now what is the next equation? It is displacement in the tth second, right? Displacement in the tth second. First I will write the equation, then we will derive it. Okay. Let's understand the difference between these two equations first. Okay. It is u plus a into t minus half. Okay. This is the equation. So here we are finding the displacement in that particular second. Okay, in that particular second. We are not taking the displacement from 0 to that. We are just taking the displacement in that. You get the difference. So it is in tth second. In tth second. Okay. In tth second. Okay. Now, example, say fifth second. Say fifth second. Okay. Which means in that fifth second, what is the displacement? In that fifth second. So, my question is, how can you find this displacement from the equation number 1? Okay, I just marked the first one as equation number 1. I need to find the equation of 2 from 1. Okay, that is how the derivation is done. Okay, we need to find the equation of 2 from 1. How can you do it? Just think logically. Just think logically. Okay, I'll explain that. I'll just explain that. Okay, here is a body. Here is a body. That body starts its journey from 0 seconds. Okay, and it have traveled for 5 seconds. So in between that there will be 1 second, there will be 2 seconds, there will be 3 seconds, there will be 4 seconds. Isn't it? So how can you find the displacement in this last second, that is the 5th second? How can you find that? What I will be doing is, I will find the displacement for these 5 seconds. Okay, then I will find this is a displacement for 5 seconds, not 5 seconds. Then we will find the displacement for 4 seconds. Okay, then what I will do, in order to get the displacement for 5th second, I will subtract this S5 minus S4. Does it make sense? So that I get this last displacement in that particular second. So this is the logic behind the derivation. Okay. Now we will go to the derivation. We will go to the derivation part. Okay, I will erase all these things and I will once again draw this figure. Okay. So what is the logic? The logic is, okay, a body starts its journey from time t equal to 0 seconds till t seconds. Okay. So what I have to do? I have to find the displacement for this t seconds, which is similar to the previous case, S5. Okay. Now I have to find the displacement for, how to get 4 from 5. 5 minus 1 is 4. So how to get the previous one? We are considering t seconds. So what is the previous second? T minus 1, right? T minus 1. That is x4, right? T minus 1 seconds. So I will find the displacement for this t minus 1 seconds. Okay. Then what I will do? I will subtract this st minus st minus 1. So I get the displacement for tth second. I get the displacement for tth second. Okay. So let's write the equation. Displacement for this tth second is equal to st minus st minus 1. How to find it? What is the displacement for t seconds? It is ut plus half a t square, right, minus, what is the displacement for t minus 1 seconds? It is u into, here the time is t minus 1, right, plus half a, the time is t minus 1 square. Clear? Okay. So let's do it. S teeth is equal to ut plus half a t square minus, okay, let's expand this, let's keep this whole thing in bracket. Okay, okay, now we'll open this, that is ut minus, okay, ut minus u, right, plus half a, what about this t minus 1 whole square? It is a minus b whole square, which is equal to a square minus 2ab plus b square. So this is t square minus 2t plus 1. Alright? Let's again do it. ut plus half a t square, okay, minus, I'll open this big bracket, so it becomes minus ut plus u minus half a t square, alright, now plus half a into 2t, okay, then you get minus half a. Let's cut the common terms. Let's cut the common terms. ut, alright, plus half a t square minus half a t square. Okay, and here this 2 and this 2 will get cancelled, so it becomes at. Okay, so what is the equation? S teeth is equal to, here u is remaining, u plus, okay, here and here a is common, right? So let's take that a outside, here remaining is t and here remaining is minus half. So this is the required equation, right? This is the required equation. Clear? So I hope this derivation and this concept is very clear to you. Okay. Then it will be more clear while we are doing problems related to this concept. So let's move on to the next concept. Next we are going to discuss about stopping distance. This is a very relevant topic and this is something all drivers should be aware about. Okay, that is, while you are driving your vehicle, you see something, some objects in front of you. Okay, think like that, you are seeing some objects in front of you and you suddenly apply the brake. Will your vehicle stop at the moment you apply the brake? No, never, right? After applying the brakes, the vehicle will move some more distance before coming to rest. That some more distance is the stopping distance. You get the idea? Okay. So the definition is also in the same way. It is the distance covered by a moving body before coming to rest after applying the brakes. Okay. That distance travelled by the body before coming to rest is stopping distance. Okay. Then, in order to cover that stopping distance, there will be a time associated with that distance. Alright? That time is called as stopping time. Okay. So, you understand the concept of stopping distance and stopping time. Stopping time means your vehicle is moving, you suddenly see an object and you apply the brake. Okay. Suddenly the vehicle is not going to stop. It will take some time to stop. After some time only it will come to rest. That time taken is called as stopping time. So let's derive the equation for stopping distance and next for stopping time. So let's see that. Okay. So we was discussing that there is a body that is moving with a initial velocity, say u. Okay. At some point, the body applied the brake. Okay. Then what is going to happen? The final velocity will become 0, right? Then, suppose this is the point where the body put brake. Okay. It applied brake. Then, this distance is called as stopping distance, right? So how to find this stopping distance S? We know the equation 2as is equal to v square minus u square. Let's apply this. Okay. This is 2 into, what about the acceleration? In this case, this is negative acceleration because the body is applying brakes. As soon as the body apply brake, then it is retardation, negative acceleration, because final velocity is 0. So it can be taken as minus a. Okay. Into stopping distance, that is S, is equal to v is 0 minus u square. So from this, minus 2as is equal to minus u square. We will cancel this negative and we will get displacement as u square by 2a. U square by 2a. Now can you relate this concept into some other concept that we have learned or discussed in this lecture itself some slides before? What is that concept? We discussed the upward motion. Do you remember the upward motion? As soon as we are projecting something vertically, okay, as soon as we are projecting something vertically, the body have retardation because the velocity is in the upward direction whereas acceleration is in the downward direction, right? And before coming to rest, at the maximum height the final velocity is 0. So before coming to rest, it travels some height, alright? What is the equation for that height? U square by 2g. Okay, we'll move some slides backward so that we can see that. Here it is, alright? As soon as it moves up, it starts retardation. At this maximum height, the final velocity is 0. So the height was u square by 2g. Okay, that similar equation is here also, because as soon as brake is applied, it starts retardation. Final velocity becomes 0, so that the displacement is u square by 2a. Instead of a, there it is g, because it is under gravity. You get the concept? Okay. Now, automatically, you will get the equation for stopping time. Alright? Relate it in the same way. Relate this concept with the concept of motion under gravity in the upward direction. Okay. We'll go for that. That is stopping time. The concept is already clear to you. Now we just need the equation, right? We just need the equation. Okay. So, there is a body initially moving with a velocity, say u. At some point in its journey, it apply brake, then it will come to rest after some time t. That time is called as stopping time. So how to calculate it? We know that v is equal to u plus at. Alright? Here final velocity is 0, initial velocity is u. What about the acceleration? The acceleration is again negative. Alright? So it is minus a, the time taken is t. So that AT is equal to U and your T will be equal to U by A. The same equation is there in the upward motion also. Instead of A, you can put G. So this is how you can relate and remember these concepts. Clear to you? Okay. Now, moving ahead, we are going to discuss about Galileo's law of odd numbers. What is Galileo's law of odd numbers? Okay. Suppose if a body is dropped, okay, then that body is in free fall. Alright, that body is in free fall. So if a body is in free fall, okay, and we take the ratio of displacement in equal interval of time, then that ratio will be odd number ratio 1:3:5:9 like that. That's the whole number ratio. Let's see whether that statement or that law is correct or not. Okay, let's verify that. So let's consider a body that is in free fall, that is initial velocity is equal to 0, that is moving vertically down. Alright? Okay. So we'll mark some positions, say A, B, C, like that. We'll consider positions A, B, C in regular interval of time. So here, this is first, second, this is 2nd second, this is the 3rd second. Okay. So we need the displacement in the 1th second, S1. Then we will find the displacement in the 2nd second, that is S2. Okay. Then displacement in the 3rd second, S3. Clear? Now we need to take the ratio and verify whether it is an odd number ratio or not. So let's do it. What is the equation for displacement in the 3rd second? It is U plus A into T minus half. Right? So what is S1? It will be equal to, the initial velocity is 0. And what about A? The A is minus G, or I just consider the other way, another sign convention. Since the motion is in the downward direction, okay, I consider the direction of motion as positive. The direction of motion as positive. Do you remember that sign convention also, right? So we'll be taking that. Okay, so we can take G as positive because G is in the downward direction. G into the time, that is 1, right, minus half. So that is equal to G by 2. Now let's find S2th. That is initial velocity is again 0. This U is always 0. Okay, for this motion U is always 0. Now what about A? It is G into 2 minus half. What is 2 minus half? Yes, it is 3 by 2, right? Yes. So it is 3 by 2 times G. Now what is S3th? That is G into 3 minus half. What is 3 minus half? 2.5, which is 5 by 2. So it is 5 by 2 times G. Okay. Now let's take the ratio between these. S1 is to S2 is to S3 is to S4 etc. is equal to G by 2 is to 3 by 2 G is to 5 by 2 5 by 2 G etc. Okay, let's cut the common terms. Which all are the common terms? everywhere 2 is common, everywhere G is common. So what is remaining? Remaining here is 1, here remaining is 3, here remaining is 5, etc. So what Galileo told is right, right? So if a body is in free fall and you are taking the ratio for the displacement in equal interval of time, then that is a odd number ratio, 1:3:5:7:9 etc, etc, etc. Okay, clear to you? Now we are moving to a very important concept. Okay, both in board examination point of view as well as in your competitive examination point of view. And this concept, which is that concept? Relative velocity. Alright, that concept is important not just in this chapter. We will be learning its continuation in the next chapter, that is motion in a plane, in many upcoming chapters, including your plus 2, in your ray optics and all. You have problems where you have to use the concept of relative velocity to solve the problem. Okay, so this is very important to understand. Okay, and I will be giving you some shortcut ideas in order to do problems easily. Okay, so first of all, let's understand what is the concept of relative. Okay, relative, you are relating something. What is that concept? After understanding that, we will come to relative velocity. Clear? So let's understand that. Suppose here is a boy. It's looking nice, right? Here is a boy A, and here is another boy which is B. Okay, and B have a height which is 200 centimeter. Okay, it's just an example. Okay, and A have a height which is 180 centimeters. If I ask you what is the height of A, you will tell 180 centimeter. If I ask you what is the height of B, you will tell it is 200 centimeter. And if I ask you what is the height of B with respect to A, you get the idea. What is the height of B with respect to A? See, it is similar to the case that, see, you are here and you are comparing your height to your friend. Okay, your friend is here and you are here. Okay, then how will you compare the height? Yes, you will stand very close, alright, and you will look to your shoulders. What is the difference in this height? Alright, that is what you are relating. You get the idea. You may have done this at some point of your life, isn't it? There will be someone who didn't done this. Basically, I have done this. Okay, okay. So let's come to this. So what is the height of B with respect to A? You will say it is just 20 centimeter, right? It is just 20 centimeters. How you get this? You will get it as 200 minus 180, which is equal to 20 centimeter. Right? Yes. So now you understand the concept of relating one quantity to another. Okay. So we will come to this concept, that is relative velocity. Let's erase this. Okay. There is a body who is moving with a velocity, say VA. And there is another body which is moving with a velocity, say VB. Okay. Then the relative velocity VAB will be equal to VA minus VB. And the relative velocity VBA will be equal to VB minus VA. Okay. You get this idea? So this is the basic idea of relative velocity. And how can you define this? When you say VAB, you are considering B as observer. B as your observer. Okay. When you say VBA, you are considering A as your observer. Okay, this is how we tell. Okay, so VAB, B is observer. VBA, A is observer. Clear? And how can you define relative velocity? We can say that it is the time rate of change of relative position. That is position, relative position by time. Relative position by time will give you relative velocity. Velocity is displacement by time. You understand that? Okay. So you can say it is the time rate of change of relative position of one object with respect to another. That another is your observer. Now you get. So actually you are getting an apparent velocity. Right? It is an apparent velocity. It is not real velocity. It is apparent. Just like the previous case, 20 centimeter. It is not the real height of that body B. Was B 20 centimeters? Never. It was 200 centimeter. But when you are relating, you get 20 centimeter. That is the apparent height. Here it is the apparent velocity. Okay. So relative velocity is apparent velocity. Clear? Okay. And I will give you a shortcut idea. Okay. It's very important. In order to solve a problem which involves more than two bodies, okay, there are more than two bodies are moving. There may be three, there may be four bodies which are in motion. In that case, okay, or in a case where there is only two bodies, for any case, this shortcut will be very useful. How to do it? That is, you have to remember, make observer at rest. This is it. Make observer at rest. Even if the observer is moving with a velocity, you have to make the observer at rest so that the problem becomes easy. Okay, we will be practicing this concept. We will be practicing these concepts by doing many problems. Okay, right now you understand make observer at rest. So, by understanding these things, let's take three cases. Okay, case 1, two bodies moving in same direction. Or we will take another case. Two bodies moving in opposite direction. We will discuss that first. Okay, two bodies moving in opposite direction. Okay, so here is a body moving with a velocity VA, and here is another body moving in the opposite direction with velocity VB, and you are supposed to find VAB. Okay, you are supposed to find VAB, velocity of A with respect to B. How to do that? I have told you, you have to make the observer at rest. So when we say VAB, your B is observer, right? B is your observer. You always draw a negative vector. Negative vector means a vector drawn in the opposite direction. Okay. Which is equal to the velocity of the observer. Okay. On every body you are considering. That's the idea. That is, okay, let's do it. We will draw a velocity in the opposite direction which is equal to VB, because B is our observer. You have to draw this velocity vector not on just this body B, but also on every body under consideration. A is also under consideration, so we will draw there also. Okay. So now you think, what is the net velocity here? What is the net velocity? The body was moving with velocity VA. Now it gets another velocity VB. And that two velocity are in the same direction. So it becomes VA plus VB. You get the idea? So it becomes VA plus VB. And what about this velocity? Here, VB is there in the right as well as in the left. Here is the body. Suppose this body has 5 meter per second velocity in the right and 5 meter per second velocity in the left. The net velocity will be 0. The body will not move to right or left. It will become stationary. Right? So that same idea here, the velocity. Net velocity will become 0. Here net velocity will become VA plus VB. How easy it is. Alright? This is what I told you. Make the observer at rest. How will you make the observer at rest? Make observer at rest by drawing a negative vector on every body under consideration. And the value of that negative vector is equal to the value of the quantity you are considering about the observer. Clear? Yes. So this is the equation. VAB is equal to VA plus VB. Okay. Now you have to draw the graph. Let's draw the graph. Okay. Let's draw the graph for this. We'll draw some more here. Okay. So we are drawing a displacement. We are drawing a displacement time graph representing this particular situation. Okay. So here VA, we know the sign convention, right? To the right direction it is always positive. To the left direction it is negative. So here your VA was in the right direction, so VA is positive. VB was in the left direction, so VB is negative, right? VB is negative. So we know that how to draw this, right? Here it is uniform motion. The body A is moving with a fixed velocity VA. The body is moving, B is moving with a fixed velocity VB, right? So how will be the graph? Yes, the graph will be like this, or I'll draw it using lines. This is for VA. This is for VA. VA have positive slope because velocity is positive. Alright? We know that velocity is the slope of displacement time graph. You remember that point, right? From the previous lectures. So VA is positive. And what about VB? What about VB? The slope have to be negative. Alright? The slope have to be negative. So this is VB. Clear? So this is the case. Now you can see that there is a particular time at which these two bodies meet, right? There is a particular time at which these two bodies meet. Suppose there are two parallel tracks. There are two parallel straight track. One body is coming like this. Another body is moving like this. So at some point they will pass each other. At some time, at some moment they will pass each other. Alright? So that time is here. Okay. Let's put it as T dash. So you get this idea. I hope it is clear to you. Right? Okay. Now Now we will move to the next case, case 2. Two bodies are moving in the same direction. Okay. Two bodies moving in same direction. Two bodies are moving in the same direction. Okay. So here is a body which is moving with a velocity say VA. Here is another body which is moving with a velocity say VB. Now you need to find VAB. Then your B is the observer. B is the observer. And what is the trick? We should make observer at rest by drawing a negative vector. So here B is the observer. So let's draw VB in the opposite direction. You have to draw this vector on every body under consideration. Here A is also under our consideration. So we have to draw VB on A also. Right? Now what is the net velocity for this body B? It becomes 0. And what is the net velocity for this V net? You think that here is a body. It has 10 meters per second in the right direction, 5 meters per second in the left direction. Then what will be the net velocity? 10 minus 5. That is 5 meters per second in the right direction. Suppose it have VA in the right, VB in the left. Suppose VA is greater, then the net velocity will be VA minus VB in the right direction. Right? So it will be VA minus VB. So that is the relative velocity, VA minus VB. Clear? So that's the equation. In this case, VAB is equal to VA minus VB. Clear? And now let's see the sign convention. Here VA is also positive, VB is also positive. Right? So how can we draw this graph? We are drawing displacement time graph. Okay. Now, as we have already told, this VA is greater than VB. Right? So VA should have more slope and VB should have less slope. Right? So we'll draw like that. VA have more slope. This is VA. And VB have less slope. So this is VB. Here also you can see that at some moment A pass B. Think of it. Get this idea. A is here, B is here. Right? And they are moving on to parallel track which is straight. Okay. A have more velocity. So what is going to happen? A and B are moving. After some time this A will overtake B. Right? Because A have more velocity. So at some moment they will meet. And that is what is T dash here. You get the idea of this graph. Okay. Yes. If you have watched my previous lectures of the slope of a graph and all, definitely it will be clear to you. Okay. Now we'll go for case 3. Case 3. Two bodies moving in same direction with same velocity. Okay, so they are moving in the same direction and also with same velocity. That is, here is a body. Let this VA is equal to V. Here is another body which is moving in the same direction. VB is equal to V. Clear? Then we know the relative velocity. We have discussed in case 2. It will be VA minus VB equation, right? So it is V minus V, which is equal to 0. Which is equal to 0. So their relative velocity is 0. What is the feeling of this case in your real life? Okay, let's have some feeling, okay, about this concept. That is, you have traveled in train, right? So, some cases there will be 2 parallel track, right? And you are sitting in a train, say A, and in the parallel track there is another train, say B. Okay. And if these 2 trains are moving in the same velocity, then you are looking from this A train to B. Okay. Then what will be your observation? What is your feeling of it? You will feel that the B train is at rest. Right? Have you ever observed it? Even in the road, 2 cars are moving parallelly in a straight road. If you look from one car to the other, you will feel that that car is in rest. You will feel yourself as in rest. Get the idea? Okay. Now, in previous case, what is the feeling? What is the feeling? You are moving in a car B. Okay, you are moving in a car B. And from back of you, a car A which have more velocity overtake you. Okay. Then when you are looking to A, you will feel a velocity which is less than its actual velocity. Okay. The apparent velocity you are feeling will be less compared to the actual velocity of A. Okay. Because it is VA minus VB. The equation is VA minus VB. You get the idea? Now, we'll go to case 1. What is the feeling? What is the feeling? The feeling is, you are moving in car A. Okay. And in opposite direction, there is a car B coming. Okay. And it passes you. You will feel the velocity of car B is very high. Okay. The apparent velocity you are feeling will be more than the original velocity of that car B. You will feel it have high velocity. And sometimes you may call some bad words, right? Upon seeing that. Actually, it is a feeling, it's a sensation that it is moving with a high velocity. Okay. That high velocity you are feeling is actually more than the original velocity of the body. So, there is physics, that is relative velocity. If you haven't observed this, from now onwards, you observe that. Okay. So, while you are moving in a car or bus or a train, now onwards, you have to observe this relative velocity, this concept. Okay. You will definitely find its application. Okay. Yes. So, let's see. So, we have to draw the graph for this third case. How to draw the graph? Let's see that. We will draw displacement time graph, right? Displacement time graph. Okay. So, this is displacement, this is time. Both bodies have same velocity. And here we consider B is ahead and A is in the back. Okay. Since both have same velocity, A will not overtake B. A will not overtake B because both are moving with same velocity. You get the idea? And also, while drawing graph, since both have same velocity, the slope of the graph should be same. Alright? So, how to draw? So this is VA, this is VB. Both have same slope. If two lines have same slope, then they are parallel. So VA is parallel to VB in your graph. Clear? So these are the concepts that we have planned for today's lecture. We have discussed about motion under gravity. We have discussed displacement in the nth or pth second. Then we have discussed stopping distance and stopping time. Then we have discussed Galileo's law of odd numbers, and finally relative velocity. So I hope you have enjoyed this lecture. You got all the concepts. Okay, then we will be doing problems related to this in the upcoming lectures. So stay tuned with EDIFIWAY Infinity. Okay, if you have any doubts, then put that in the comment box. If you like the lectures, then share to your friends, because sharing is caring, right? Okay, so see you all. Bye bye.